Hi, Bruce Wood from Tinius Olsen, Customer Service Manager here. I'm introducing you to the plastic impact range from Tinius Olsen. Behind me we have the 504 plastic impact. As it stands, this does not have any additional weights on it. The capacity of this machine is around about 2.5 joules. With additional weights, we are able to increase the capacity up to over 20 joules. We also have options for a heavy hammer, allowing you to get up to almost 50 joules of energy from the plastic impact, should the product require it. The display that we use on the 504 is the same display that we use on our metals impact. So if you're familiar with that machine, the controls and the menu structure is identical to allow you to operate the machine. The machine needs to be affixed to a table securely, and it must be leveled. The machine we have behind me is actually sitting on feet for demonstration purposes, but if it is being used in the laboratory, it must be securely fastened to a solid table and level. The options for the machine are, we can do, as it stands at the moment, we can do IZOD testing. IZOD testing is where the sample stands upright. So the sample is an upright sample like a letter I, allowing it to be struck and broken in the direction of testing. The other test method for impacts is Charpy, where the sample is laid horizontally and is hit in the center of the sample and broken through the center. This machine is capable of doing both of those test methods to both ASTM and ISO specifications. However, because the Charpy for ASTM and ISO have different spacings and different properties for the striker and anvils, you are not able to perform both of those tests on the same machine at the same time. However, it is perfectly capable of doing IZOD testing while Charpy anvils are in place, and then just switching out the striker on the machine. So let's introduce you to some of the components of the machine. As it stands at the moment, this machine is set up for IZOD testing. We have the pendulum, and we have some vacant spaces on the pendulum. This space right here and this one right here allow us to accommodate additional bolt-on weights. The weights come in various capacities and sizes. This weight that I'm holding in my hand is half of a set of weights. They actually come as a pair, which actually are two weights that clamp either side of the pendulum through these two holes. This allows us to increase the capacity of the pendulum in increments to allow us to test a wide range of materials without changing out the pendulum or the striker. The lightest weights are made from aluminium to allow us to get to the correct load. And as we go up in capacity, we switch over to stainless steel to allow us to continue in the range. We have the striker on the pendulum, which can be replaced. It is held in place with 2 bolts and a locating pin to ensure its correct location. This striker can be changed out, as I stated earlier, to allow us to switch it to a Charpy striker. This one I have in my hand is actually for the ASTM D6110 standard, and then it fits in the same physical location. The pendulum itself can have the height adjusted. So this arm that we have set right here has 2 clamping bolts on the clamping collar here to allow us to adjust the height of the arm, allowing us to adjust the height at which we drop the pendulum from, and therefore changing the impact velocity to comply with any of the specifications of either the ASTM or ISO. The vise body on the bottom of the machine right here, it has a notch locator, allowing us to locate the notch on the sample. So the samples that we test are notch samples, and this notch locator allows us to locate the sample correctly when we place it in the machine, so that when we clamp it, it is correctly located for the test. We also have a centering gauge. This allows us to center the samples so different thicknesses of samples can be accommodated on the center line of the machine. The clamp itself has a socket head cap screw on the back here to allow the samples to be torqued to the same torque every time they're placed in the machine. The vise body at the back here, as you can see at the moment, I actually have 1 anvil placed here. This is actually a Charpy anvil, and as it's out of the plane of testing, this can remain in place along with the one on the front here when I set those up to allow the Charpy and IZOD testing setups to remain intact during the testing. As I stated earlier on, the machine must be bolted to a table. There are 4 locations in the corner here that would accept a standard cap head bolt that can be bolted down through a table. And obviously shims would need to be used to level the machine before it's actually tested. The display on the machine right here, this plugs into a regular outlet. It will accept 110 to 240 volts AC without any changes required. And this allows us to set up the tests, allows us to change the capacity of the pendulum, and allows us to perform a calibration upon the machine. This machine, the 504, is an open machine. The 503, which I'll introduce you to a little later on, that's an enclosed machine, but the basic mechanics of the machine itself are identical. There are no differences between them.